Hello everyone. Today we are going to see about transducer. A transducer is a device that converts one form of energy into another. A transducer is something which converts the property we want to measure into some other form. Easier to work on, easier to amplify, easier to transmit to another place, or more suitable to operate a display unit. So this is the block diagram of a transducer. Any physical quantity we can give input to the transformer, transducer. So we will get the electrical output. A detector senses the input information and the transducer converts it into a more convenient form for a subsequent stages of measuring system. There are various type of transducers available. One is mechanical transducer, electrical transducer, and active and passive transducers. Finally, we have analog and digital transducer. The mechanical transducer displacement is the output quantity of most of mechanical primary detector transducer and their operations are given below. So here in this table, what type of transducer available in the mechanical as well as it shows or it gives an application of the transducers. So first one is contracting spindle, displacement to displacement, elastic members, spring, bottom tube, bellows, proving ring, diaphragms. So spring is force to displacement, bottom tube is pressure to displacement, and bellows also pressure to displacement, proving ring, force to displacement, diaphragm, pressure to displacement and mass, static, hydropneumatic, and dynamic thermal. So here, seismic mass, manometer, pendulum, float, hydrometer, venturi, orifice, pitot tube, vane, turbine, thermometer, bimetallic stripes, thermocouples, thermistors. So here, what are the operation? Mass having a force to displacement, pressure to displacement, force to displacement. Fluid level, second one is static, hydropneumatic, fluid level displacement, and hydrometer, specific gravity to displacement, and dynamic hydropneumatic, venturi, velocity to pressure, orifice, velocity to pressure, and then vane velocity to force, turbine linear to angular velocity, thermometer temperature to displacement, bimetallic strips temperature to displacement, thermocouples temperature to electrical, and thermistor temperature to resistance. Next one we are going to see about electrical transducers. The displacement is the input for the most of electrical transducer. The quantity to be measured is first generated and transduced to displacement of a mechanical element. An electric device then serves a secondary transducer, transforming an analog displacement into an analog voltage or current. Advantages of electrical transducer. The effect of friction and vibration are minimized. While we are using electrical transducer, the friction and vibrations are minimized and mass inertia effects are minimized and lowest power consumption, more compact instrumentation, good frequency and transient responses. Amplification can be easily obtained. Remote indication and recording is feasible. The mathematical processing and the signals are obtained. So in electrical transducer, we have various types. One is a variable resistance types, variable capacitance type, and a variable inductance type, voltage generating type. So each one have different operation and different applications. So here the thermocouple, piezoelectric couple, pickup, and the photovoltaic cell, electrical tachometer, eddy current gauge, and reluctance pickup, linear variable transformer, so everything is have some applications and using the operation of electrical transducer. So as you can see this thermocouple is a temperature to EMF. The application is temperature and heat flow. Likewise, piezoelectric pickup, force to EMF, pressure variation and acceleration. Photovoltaic cell, light intensity to voltage. So we'll have a solar cell. Active transducers are self-generating type and develop their own voltage or current. The energy required for production of an output signal is obtained from the physical system being measured. Example, thermocouple, piezoelectric pickup, photovoltaic cell, etc. So these things comes under electrical transducer as well as active and passive transducer also. The passive transducers are extremely power type and derive the power required for energy conversion from an external power source. However, they may absorb some energy from the physical system being measured. Example, a resistance thermometer, thermistor, and LVDT. Here, the LVDT is linear variable differential transformer. So, in this one, we'll have a displacement to electrical signal, analog and digital transducer. Analog transducer are converted into input into analogous output, which is a continuous function of time. Example, thermocouple, thermostat, strain gauge, and LVDT. So, as you can see that the analog and digital transducer, active and passive transducer, and electrical transducer, and mechanical transducer. So, most of them have a same applications, but its operation is belongs to either electrical transducer or mechanical transducer or analog and digital transducers. The digital transducers are convert input into an electrical output, which may be in form of pulse. Example, electromagnetic frequency domain transducer, digital encoder transducer, auto-electrical frequency domain transducer, etc. Advantages of digital transducer. Use of digital computers along with the transducer for data manipulation is made easier. Okay. Digital signals, pulse count frequency, or sequences of digital coded outputs are not dependent on signal amplitudes and are thus easy to transmit without distortion and external noise. Increased accuracy in pulse count is possible. So these kind of transducer we are using in FPGA as well as Xilinx and HDL coder in MATLAB, and finally we have a waveset controller which is using a pulse count as an input and given the pulses to the any gate signal. Thank you.